Guys, welcome to learning microcontrollers. In this video lecture, I'm going to show you what is UART. UART is a very common name for the electronics and embedded engineers. Even the software engineers are now familiar with it. UART is a very common protocol found in various sensors and modules, and nearly every microcontroller in the world now have a UART port. Without the UART port, that microcontroller is not considered to be a very latest or an advanced microcontroller. So what is UART basically? In this video lecture, I will tell you about the UART in some descriptive and you can call it a graphical way. I will tell you how this works because we all know the theory that like UART is a serial communication. Now what is serial and how it works? So that's where we will get into it. So first of all, UART. U stands for universal. This means that it's a universal type of protocol, or you can call it a standardized in whatever the microcontroller, whatever device, whatever sensor, whatever module you find the UART, it will be exactly the same in any other device. Like they all will be same. So it's a type of a standardized type of a protocol being used all over the globe. A stands for asynchronous. Asynchronous means that it do not rely on clock. It sends data in the form of packets or it sends data in some other way, but it do not rely on clock. That is what asynchronous means. Receiver and then transmitter. This means that it can receive the data and then at the same time the same port can send the data as well. So it can do both. It can receive the data and it can send the data at the same time. Now guys, the next thing is how many wires you need to make it work. You basically require 3 wires to make the UART protocol or UART port to work. Suppose you have this UART port. It can be on your microcontroller or a sensor or a module or a camera, whatever you have. Wherever the UART port is situated, you will always find these 3 pins, TX, RX and ground. Now TX is to send the data, RX is to receive the data, ground is a reference, like you comment the ground for both the devices. Now to make the things further clear, I will take another device. Suppose we have another UART port, like the left one is our microcontroller, the right one is another microcontroller. This also have a UART port having the same pins TX, RX and ground. Now let's do the connections. Let's connect them together. How we connect them? Ground goes to ground. Obviously we know that we have to comment the ground. Then TX of the first device will go to the RX of the second device. Now this is what looks a bit complicated for the new people. Why the TX goes to RX? We know that if I send data from the first device and I connect it to the TX of the second device, then how they are going to communicate? The TX must be connected to the RX, so whatever the first device is sending, the second device is receiving. So like I speak to you from my mouth, you listen to me from your ears. So my mouth is connected to your ear through a medium called air. So let's do that for the other pin. Now the RX of the first device will go to the TX of the other device. Now you can see that TX of the first device goes to the RX of the second. The TX of the second device goes to the RX of the first. This means that they both devices can send and receive data at the same time. So that is the beauty of UART port. Now one thing you can see is missing. What is missing? We cannot see a clock over here. See? Now that is the beauty of the UART. Another beauty of the UART is that it's asynchronous. It means that no clock is required. Like clock is very difficult. Like in case of us SPI protocol, it is very difficult to synchronize the clock and other stuff. So here you have no clock. So it is very simple to use. Now guys, the next thing is we must know that UART is a serial communication. All of us knows this, whoever have ever used a UART port, that is serial communication. But what does it means? But before I tell you what is serial communication, I tell you what is parallel communication. We must know what is parallel and why we go for serial. Now suppose we have a device A and then we have a device B. They can be microcontrollers like a microcontroller A and a microcontroller B. Then I connect them together using 8 pins or 8 wires. Suppose device A is an MCU, device B is an MCU. I interface them using 8 cross GPIO pins. I connect the 8 GPIO pins of device A to the 8 GPIO pins of device B like this. Now guys, the next thing is we want to send this data. Like we want to send 8 bits 0 1 1 0 0 0 1 1. We want to send this from device A to device B. What will happen in the case of a parallel protocol? Like this, they will be like one bit will be assigned to one wire and then they will go like this parallelly. See, this is what is going to happen in case of parallel communication. Now let's see what is serial communication then. Now suppose again we have a device A and device B. This time again we want to send the same data, that is 8 bits, and here we will have only one wire. You can call it like TX to RX. Device A is the TX, device B is the RX. So TX of device A is connected to the RX pin of the device B. Here the data will be sent like this, one at a time, serially. So device A will send 0, 1, 1, 0, 0, 0, 1, 1, one by one. And if we go into it, it will look like this, the serial communication. See, we have this curve. Here this side is 0, then it became 1. It will look something like this, like we started our UART protocol at falling edge. And you may like set it to the rising edge as well. Like by default it is at 1 or by default it is at 0. It doesn't matter. So in our case it starts like this from the falling edge. It became 1. Then again it remained 1 and then it fell to 0. Then 3 times it's 0, 0, 0. See, 3 zeros. And then again it became 1 and then twice 1 and then again 0. So it will look something like this. That is how this serially it will send the data. It will send data in this way to the second device. Now guys, this side is the TX, this is the RX. But in case the other pin is also connected, like UART port have 3 pins, TX, RX and ground. Now we have only connected the TX to the RX. Ground is obviously common. So the other side, this will happen the same. Like this time, at the same time, we are sending the same data from device B to device A. The same will happen like this, TX to RX. Simple as that. Now guys, the problem lies in the fact that now we don't have any clock over here. How we analyze that, what will be the speed, how much time it takes? Now that's a problem. We don't have the clock. I want to send this, but with what thing I will synchronize it? Like we usually say that in the data sheet, go check the clock diagram, see how to send and receive the data, but there is no clock in case of UART. So in that case, they have another concept called BPS. BPS and UART defines the speed. BPS. BPS stands for bits per second. How many bits are going per second? That's why we no longer need the clock in asynchronous UART communication. So let me make it further clear. This defines the speed of data transfer. Now suppose we again take the same scenario. Suppose our BPS is 9600. We set the baud rate to be 9600. Now what does this mean? This means that here we sending only a packet of 8 bits. Like in our case, we are sending just these 8 bits, 0, 1, 1, 0, 0, 1, 1. We can send 9600 bits in 1 second. That is what 9600 BPS means. See, maximum length of this wire in 1 second, maximum length of this data packet in 1 second can be up to 9600. So it can send 9600. If you want more speed, like I want to send more data in less time, then increase the baud rate. Like 115200 is very commonly used. You may go for higher baud rates as well if your microcontroller or your device supports. Usually if the device B is a sensor or a module, then it comes in its data sheet that what is the baud rate you have to select to communicate with this device. The baud rate of the receiver must be the same as that of the transmitter to send and receive that data. And in case this is another microcontroller, then you have to set the same baud rate for both the devices. Like if device A is working at 1200 BPS, then device B must be at 1200 BPS, else your communications will not work. So guys, this is simple as that. So this was it. Some basic introduction to UART communication. I hope you guys learned something from this video. Finally, I give you a demonstration of the PIC16F877A. If you guys are interested in PIC, then take a look at this slide as well. Like suppose we have two PIC16F877A microcontrollers. I'm just taking this for an example. In the PIC16F877A, you have one UART port and it is located at pin number 25 and 26. Pin number 25, that is pin number C6, is the TX. Pin number 26, that is pin number C7, port C, pin C7 is the RX. Now, if I want to connect these two microcontrollers together, I have to connect the RX pin of this microcontroller to the TX pin of this microcontroller, like this, TX to RX. Like pin number 25 of one microcontroller will go to the 26 of the other. Similarly, for the second wire, do the opposite. Connect the pin number 25 of this microcontroller to the 26 of this microcontroller. So TX to RX, RX to TX. And finally, the ground must be common. So this is how it's gonna work. So guys, this is it. If you guys have any question, please do ask. We'll see you in the next lecture. Goodbye until then.